Hi, I'm Jan Janosch, fourth year electrical, electronic engineering and IT student at QJ. I think everybody's familiar with these. They are called quadcopters, and they're very nice and easy to work with because of the four propellers. Doesn't matter which axis we're looking at, we always have symmetry. And they are used a lot for aerial photography and those sort of things. But for my project, I went a little unorthodox and I chose to build a tricopter, which consists of only 3 propellers instead of 4. Now, if you think about it, that symmetry that we saw in the quadcopter does not exist in this one anymore. If we consider this the half, there's 2 propellers at the back and 1 at the front. So, and also to control this movement, this motor is on a axis, so it can tilt, and that will make the tricopter what we call move in the yaw direction, or have yaw movement. Now, so a lot of interesting control theory had to go into making this fly, which is a little bit harder than the quadcopter. Now, initially, I used a PIC microcontroller, and I used through-hole components to first lay out a PCB, and this was used to develop the control algorithms and the code, but this proved to be bulky, so a surface mount component board instead was developed. In addition to having my name and UJ imprinted into the cell screen at the bottom right, this board houses all the components needed for the flight controller. So the body is 3D printed. All these components, it's easily printable by itself. Then it has a accelerometer and gyroscope unit on top, which measures the orientation. Now, every motor has its own speed controller that drives the motor on the side here. And if you look at the tail assembly in detail, this is what makes the tricopter move in this direction. Interesting enough, if I want to go in this direction, I tilt it like this. Not only does it go like this, but like this as well. So that's extra element that needed to be compensated for. Inside there is space for a 3-cell lithium battery. It also houses all the complementary components needed to realize the tricopter. The PCB shown earlier is here implemented as well, with all the components soldered onto it, ready to fly. Shown in the video is the actual tricopter flying. Now, going from an idea to putting in all the work to get a circuit going, to writing every single line of code to make this tricopter fly, gives you all the satisfaction in the world. Producing tangible products like this, which you can show to people, is what makes engineering worthwhile.